Hello everyone, my name is Dr. Ramkrishna Lodhi. I am an assistant professor of mathematics at SIT Pune. Today I am going to discuss numerical solution of nonlinear equations. First we describe here nonlinear equation. Nonlinear equations involve polynomial of degree greater than 1 or involve function like exponential, trigonometric, logarithmic, etc. For example, we have considered here nonlinear equation sin x minus x equals to 0. This is a nonlinear equation because it contains trigonometric function sin of x. Then we have to find the value of x which satisfy this equation. If we try to find the value of x which satisfy this equation by direct method, so we are not able to find the value of x. Then for finding the value of x, we need to study the numerical method. So in this presentation, I have considered bisection numerical method for finding the root of nonlinear equation. So first we describe here bisection method. Bisection method is a simplicity iterative method to solve nonlinear equation. Then describe the procedure of bisection method. So let the function f of x be continuous in the interval a to b. Decide initial values of a and b that would bracket the roots. Calculate f of a and f of b. Then multiply f of a and f of b. If f of a into f of b is greater than 0, then the root not lies between a and b. If f of a into f of b is less than 0, then the root lies between a and b. Then we have to calculate the average value of a and b. It is denoted by x1. It is also known as first approximation. Then we have to calculate the value of f of x1. If f of x1 is become 0, then x1 is become root of the equation. And if f of x1 is not equal to 0, then we have to calculate the multiplication of f of a and f of x1. If f of a into f of x1 is less than 0, then the root lies between a and x1. Otherwise, root lies between x1 and b. Repeat the procedure till the desired result is obtained. This is a graphical representation of bisection method. We have considered the function y equals to f of x, and here is a 2 points a and b. Then we have to calculate the value of the function f of a and f of b, and both have the opposite sign. So we can say that root of the equation lies between a and b. Then we have to calculate the x1. Suppose that x1 is here. Then we have to calculate the corresponding value of y. So we get here, and both have the opposite sign, means f of a and f of x1. So we can say that root of the equation lies between a and x1. Then we have to calculate the x2, and we have to continue this process till the desired result is obtained. We consider the numerical example. Solve the equation x cube minus 9x plus 1 equals to 0 for the root lies between 2 and 3. Answer should be correct to 2 decimal places. So here is a mention, we have to continue this process till the answer is correct to decimal place. So let f of x equals to x cube minus 9x plus 1, and it is also given root lies between 2 and 3. Then we have to calculate the f of 2 and f of 3 and multiply f of 2 and f of 3, so it is become less than 0. So the root of the equation lies between 2 and 3. Then we have to calculate the average value of 2 and 3. It is denoted by x1, or known as first approximation. So we get that x1 equals to 2.5. Then we have to calculate the f of x1. So f of x1 is become minus 5.8. It is a negative sign. Then the root lies between 2.5 and 3. Then we have to calculate the second approximation. So we get x2 equals to 2.5 plus 3 divided by 2. So it is become 2.75. Then we have to calculate the f of x2. It is also have negative sign. Then the root lies between 2.75 and 3. Then calculate the third approximation. So x3 is become 2.75 plus 3 divided by 2 means 2.88. Then we have to calculate the value of f of x3. It is become minus 1.03. Then the root lies between 2.88 and 3. Then calculate fourth approximation. So x4 is become 2.88 plus 3 divided by 2 equals to 2.9. Then we have to calculate the value of f of x4. It is become minus 0.05. Then the root lies between 2.94 and 3. Then we have to calculate the fifth approximation. So x5 is become 2.94 plus 3 divided by 2. So it is become 2.97. Then we have to calculate the value of f of x5. It is become 0.47. Then the root lies between 2.94 and 2.97. Then we calculate the sixth approximation. X6 is become 2.94 plus 2.97 divided by 2 equals to 2.955. Then we have to calculate the value of f of x6. It is become 0.21. Then the root lies between 2.94 and 2.95. Then we have to calculate the seventh approximation. So x7 is become 2.94 plus 2.955 divided by 2. It is become 2.9475. Then we have to calculate the f of x7. It is become 0.08. Then the root lies between 2.94 and 2.9475. Then we have to calculate the eighth approximation. So 2.94 plus 2.9475 divided by 2, it is become 2.9438. So we calculate the value of f of x8. It is become 0.017. Then the root lies between 2.94 and 2.9438. Then we have to calculate the ninth approximation. So x9 is become 2.94 plus 2.9438 divided by 2. So it is become 2.9419. Then we have to calculate the f of x9. It is become minus 0.016. Then the root lies between 2.9419 and 2.9438. Then we have to calculate the 10th approximation. So x10 is become 2.9419 plus 2.9438 divided by 2. It is become 2.9428. So if you see the value of x9 and x10, so x9 is 2.9419 and x10 is 2.9428. Both are the equal, correct to 2 decimal place. This is our required solution. So 2.94 is a root of the equation x cube minus 9x plus 1 equals to 0. Thank you for watching.